So we're dealing with inequalities. These are things that have greater than, less than signs in them, such as these shown here. When we're graphing an inequality and finding the solution, we're actually finding more than one point. If we're solving an equation, we get one answer, such as x equals 5. But with an inequality, we get regions. Now, depending on the direction of the inequality sign, we will always have a line. It may be dotted, it may be solid, and as we go through examples, we'll see the difference of when to expect dotted and solid. But we will also get shaded regions. So in some situations, any point in that area could be a solution. In other situations, any point in this area could be a solution. So in the beginning, we're going to use a graphing calculator to help us to see that. But first, we do need to actually do a little bit of work by hand to get this in a format that's compatible for the graphing calculator. To do that, we need to take the inequality and we need to get y by itself. So if we have 2x plus 3y less than or equal to 6, we need to isolate y. Easiest way to do that, subtract 2x from both sides. Leaves us with 3y is less than or equal to negative 2x plus 6. Then we need to divide everything by 3. So we have just y on the left now is less than or equal to. We can't simplify negative 2x over 3, so we'll just leave it as is. But we can simplify 6 over 3, that is 2. So we'll turn over to the graphing calculator for the next bit. If it's the first time taking one, make sure we do a full hard reset. Second plus 7, 1, 2. And in order to input this inequality in the calculator, we need to go to y equals. But as we can see, every single equation there is y equals blank. Now, we don't have an equals in this inequality. We have less than or equal to. We need to find a way of creating that. We do that through an app on the calculator. So we go to apps. Mine only has 2. Yours likely has more. But we want the inequalities app. So it's number 2 on mine. Pick whichever one it is on yours. Hit enter to launch the app. Tells us to press any key. And now it alters the standard y equals screen. So now we have what are called soft keys at the bottom of the screen. Equals, less than or equal to, greater than or equal to. What we need to do is we need to match that sign to the one we have. Ours is right here in the middle. It's above the zoom key. Now, in order to switch the sign and make these soft keys function, we have to press alpha before we press the key. And we can see that the sign has changed. In order to input the second half of our inequality, we need to arrow over off of the signs. You see those soft keys disappear. And we need to input negative 2x over 3 plus 2. So it would be the white negative 2x divide by 3 plus 2. If we hit graph, we can see we do have a shaded section. It shows it as lines, but it really means that anything in that lower part of the graph qualifies as a solution. We have a line. It is a solid line. I'll get into the difference between solid and dotted on the next example. But this would be what we have to copy out onto the graph. I'm going to do the best I can to put it here, but again, my drawing skills are not great at the best of times, and this is definitely not the best of times. So we have a graph that looks something like this, and the shading is here. You can scribble in, do it how you want, but anything in that lower section qualifies as a solution. So before we get to part B, Just going to do some brief calculated instructions. We need to open the apps. We need to choose the inequality app. In order to change off of an equal sign to whichever inequality sign, we need to use the alpha key. We need to input the inequality, and we need to graph it. So question B now is determining whether or not the point that I've given to you is actually part of the solution. So the point that I've given is negative 2, 4, which is right about here in red on that graph. Now, any point that I give you can be in one of three places. It can be inside the shading, as this one is. It can be outside the shading, or it can be exactly on the line. Since this point is inside the shading, then that means it is a part of the solution. If that point had been outside the shading, it would not be part of the solution. And if it was on the line, it would depend whether or not it was a solid or a dotted line. If it's on a solid line, it is part of the solution. If it's on a dotted line, it's not.